So in economics, there's many different ways of representing the same problem. You just have to make sure that it all makes sense when you're kind of going through this process. Different textbooks will have different techniques, different websites. So if you understand how things work, you're going to be in a better posture to figure things out in the future. So today we're going to focus on pollution taxes. And the thing that to notice with economics in general at a undergraduate level mainly is that a lot of these problems we deal in a very static framework and a very partial equilibrium kind of analysis versus in more advanced courses we could have more of a general equilibrium analysis. So let's just kind of mention that for a second, partial versus general. So partial, we're just looking at one thing changing at a time. So there's like just one or few things that change, one thing changes. And we look at the impact on the specific thing that we're focusing on. Whereas general, we're kind of putting everything together. So if I have the price of carbon go up due to carbon taxes, well, it's going to have an influence on like the price of fuel and other things like that. That's going to have a higher tax, but then it's going to have also an impact on transport, which will then have an impact on a bunch of other goods, which will have an impact on salaries, which will have an impact on the economy in general. So there's just kind of like, this is more like the chain reaction kind of effect, whereas partial equilibrium is really just kind of looking at one piece of the chain. And when it comes to pollution taxes, different textbooks, as I mentioned, you can have a focus on having these kind of marginal abatement cost curves and marginal benefit curves. So if I think of these curves, which one's upward sloping, which one's downward sloping, well, it really depends on what's going on here. So is this here the level of pollution reduction, or is this here the level of pollution? So if I go from, let's say, 100 units or 100%, let's just keep it as 100 units here. Well, if this is 100 units of pollution and over here this is 0 units of pollution, well, I'm reducing pollution going that way. There's got to be a drop in pollution. Okay. On the other hand, I could have that this line here represents pollution reduction. So if I think about reducing plastics or whatnot, well, I could be going from like 0 to over here, the limit would be 100% reduction. There's no more pollution out there. Here, there's 0 pollution reduction. And here we're talking about units, so going this way there's less pollution, and in this case here going that way there's less pollution. So depending on which of the two will determine whether it's abatement costs or benefits that are upward sloping or downward sloping. So don't need to remember this by heart, just try to make sense of it. If I think of this being pollution reduction, well, as things go, I'm going to have more benefits from this reduction in pollution. However, we know that the benefits are greater when there's a lot of pollution and we reduce it than when there's just kind of like a few wrappers going around. So actually, the marginal benefits curve would be this way. And if I were to reduce pollution, it's easy to pick up garbage bags or other kind of plastic products when there's a lot around, because you just have to kind of take a quick walk and you could fill up the trunk of your car if there's like tons of it. But when there's very few around, when you've already reduced pollution by 95%, going all the way to 100% is a lot of time and a lot of costs. So here would be my marginal abatement costs. Whereas on this other hand here, when I think about going from here to here, this is my pollution reduction going in that direction. Here I have 100 units and over here I have less. So in this case here of reducing those units leads to more marginal benefit. And then when I only have a few units left, the benefit's not that high. But the costs go up the more and more I try to reduce. Okay? And both of these lead to kind of like an equilibrium quantity and equilibrium price that we should achieve for efficiency purposes. Okay. So, and that could help us determine the tax that we should charge, because we know that these are the abatement costs by the company. If the company could simply remove, change something in their business to abate at a much lower cost than the actual tax, they would. So in this case here, this would be the pollution tax over here. So if they're able to just say, well, I'm going to change light bulbs, I'm going to change other things that are very cheap for me to change to avoid releasing those carbon emissions right now, I'm going to save a lot of money, and I'm going to keep doing that till it starts becoming costly for me, that I'd rather just pay the tax for the remaining level of emissions. So that's how typically we see things happening in environmental economics. Whereas in microeconomics, for the people who've done this before, you should have had a view of this before. Well, we're looking at supply and demand of two different goods. So here when I look at supply and demand, so this is amount of goods produced. So this is like a specific good, so it's a quantity of a good. Whereas over here, we're talking about like pollution level, and over here like pollution percentage. So this is quantity of a good, whatever it may be, like a hammer or whatever else. And these are the different prices. People are willing to pay more if they don't have a hammer. They'll be willing to pay more for the first unit than the second unit and whatnot. And then there's the supply curve, or this private cost curve, marginal private cost curve. And this normally establishes the equilibrium price in a situation where there is no tax. And when we introduce a tax, there's different ways you could do this. You could either have the curve shift, or the way I prefer to do it is just imagine that I introduce a tax of this amount. Let's say over here, this is $7 and this is $5. Well, my tax is $2. So there's a gap between what the producer receives of $5 and what the consumer pays of $7, and that's the $2 tax. And in microeconomics, we've seen that it doesn't really matter whether this tax is imposed on the buyer or the seller, it's going to have the same impact altogether. So there's often this discussion of like, well, can the seller just pass on the tax to the buyer? And that commonly happens when we have what we consider a very inelastic demand curve. It could even be more vertical than this if we have practically no substitutes available for this specific good. So if I think of this good here, this used to be the price paid, and now I introduce a tax, and most of the change in price has been going to the consumer, and the producer just sees a small drop in the price that it receives. So this is the case when we have an inelastic product. So inelastic, this is where we have very few substitutes, and it's a situation where pretty much the buyer has to buy it because there's very few substitutes, which mean that the producer, even if they were imposed a tax, they could pass on this tax, this cost, to the buyer. So the difference that we can notice in these two kind of analyses here is the fact that over here, we're looking at like abatement costs involved by the producer. So you could think about just evaluating, well, how much would it cost to change your fleet of trucks to having an electric fleet of trucks? So how much would you save on transport in terms of emissions, and at what cost would that come to you? And that would establish the abatement costs. But over here, this is more in that general kind of, even though it's very simple still, it's more in that general framework that we're not only considering like this price increase that might be due to this carbon tax of this level, while we're looking also at how does the consumer behave, how does the supplier behave, and is it possible for the supplier to just pass on that cost to the buyer? So in this case here, it's easier for them to just kind of pay the tax and pass on the cost to the buyer. It might be cheaper still than abating. They'd still abate like whatever they can that has the least amount of costs over here, because they wouldn't likely be able to pass that on to the consumer. But certain of the things that would be more expensive, they'd be able to pass it on. But if we have a situation, on the other hand, which is more kind of like more equivalent in a certain way, that we don't have a very steep supply curve or demand curve, or compared to this very steep one, or we have a situation where the demand curve is quite flat relative to the supply curve. Well, in this case here, this initial price was here, the seller wouldn't be able to pass on that cost to the consumer. And therefore, they would have to pay for this tax because the consumer here has a lot of substitutes. So when there's very few substitutes, they could pass on the cost. If they have very little substitutes, they can't pass on that cost. Which brings me to another point in all of this story if I think about carbon taxes. So if you want to reduce carbon, you have different tools available. One of those is a tax, which is an increase in the price because of a tax, because you have an increase in the tax. Well, if your goal really is to reduce the quantity of emissions, you got to make sure that you're actually reducing emissions. And here you could see that emission reduction is quite substantial. It's not half, but almost. And over here, it was much smaller, and it's because people react less. So you need to understand people's reaction. And the reaction is greater the more substitutes you have available. So the moral of this story is if you want to be able to alter their consumption behavior, you need to make sure that there is substitutes available. Okay? If you're asking everyone to stop consuming fossil fuels, well, it's easy if there is an alternative. But think about just about any good out there that the government might say, we want you to stop consuming this good. But there's no alternative for you. We want you to get off of any of these fossil fuels, but you don't have access to hydroelectricity, any of the renewable energy. You have access to nothing else. And it gets really cold in the wintertime. Well, how are you going to heat your house? So you got to make sure that there's substitutes available, and something that could help with that is just kind of subsidization and clean technologies. So once that happens, yes, it's going to make these clean technologies cheaper, and relatively speaking, they may eventually become cheaper than the dirty product, as we start seeing with electric cars. If you look at the cost of an electric car over its lifespan versus a gas car, it's typically lower these days, and it's just going to get lower and lower and lower over time. So if you have that situation with a clean technology, it makes it pretty easy to switch over. But just having access to that clean technology, if we think about fuels that could currently be used in airplanes that are greener, well, if we look at those fuels, it's going to be great because it's going to make it that if you increase the price of the dirty fossil fuel that goes into those planes, well, at least they're going to have an alternative. Because otherwise, imagine a situation where there's planes, but there's no alternative. Well, the only alternative to reducing greenhouse gas emissions is if you put the price up so high, price of flights will be up so high. So if you put the price of like fuel for planes up, well, then it's going to make the price of the flights go up. And then you're going to have a situation where people fly less, which reduces the output of carbon emissions, obviously. So if all else fails, that is possible. However, it's cool if you can go through this process faster, or go through this process without having people having to limit themselves so much if you like to travel and so on, by having an alternative. Anyways, hopefully this whole kind of diagram here helped you understand the different ways that we can see pollution taxes graphically, going from microeconomics, going towards environmental economics, how they're different, how they're interconnected, how sometimes we treat things too much on its own, which is good for analysis and a graphical framework, but you still want to keep in mind all the little details, because those little details might give you an idea of what the perverse effects may be from any of these policies. I hope you enjoyed it. I'll talk to you guys soon.